Good morning, everyone. Thank you for having me at this session today. I'll be talking about UHPC overlay installations, particularly from a contractor's perspective. I've been in the UHPC industry over 15 years, and lately I've been doing a lot of work in UHPC overlays. UHPC solutions, just quickly to give an overview of that, it's infrastructure rehabilitation contractor. We're a contractor, we're not a material supplier. We have a lot of experience in mixing, installing, transporting, and placing UHPC. We use UHPCs from various different material suppliers, and we have and select the one that makes a lot of sense for each of the projects. We have a very experienced workforce, and we have very cutting-edge equipment to install UHPC. We have a lot of focus on overlays, but we also do bridge connections for precast bridge deck elements, as well as link slabs, and we do shotcreting and any other type of application. We're doing the work across the US, and we do also the surface preparation for hydro demolition. UHPC Solutions is a combination of two companies, Basilico and Wallow. And in the US now, I think we are the only contractor that has installed over 10 bridge structures in 5 different states with UHPC overlays. And we have a lot of experience also in Europe, where we do a lot of work in installing UHPC overlays. Overlays, they are an excellent rehabilitation method for existing bridges. They can be, especially when you have a bridge and you really want to extend its service life. And you can use it for 2 types of applications. You can do either just a repair for durability to extend the life, or you can also do structural repairs. Generally speaking, when there's a durability repair, 1.5 inches, 1.25 inches minimum, because you have a lot of construction tolerances as well, up to like 1.75 inches are placed on an existing bridge deck. And we really take advantage of the durability capabilities of UHPC and make this impermeable and water resistant. The other thing is there's a lot of structural applications. We've seen some where we have to go below the top rebar mat of an existing deck, or some other applications, there's additional stiffing required and get more structural capacity out of deck. Rebar is being added to the UHPC overlay. Then there's 2 different types of finishes that you can see. In Europe, it's very common that they place a layer of asphalt on top. In Europe, it's preferred to have a more smoother riding, or they really enjoy that finish on a bridge deck. Whereas here in North America, we're really looking and take advantage of the durability capabilities of UHPC. Either just grinding is being done, there's decks out there, or you can see here is you have grinding as well as grooving, which gives you a much smoother and it's a more desired riding surface for a deck. What I really want to talk about in this presentation is what are the key success factors for UHPC overlay, and to be successful and what needs to be done. There's really 6 things, 6 important items. One is the surface preparation. You need efficient mixing. You need material supply that is consistent and constant, so you can have a continuous placement. There's a lot of C's, but those are very important. As well as then the overlay needs to be properly consolidated and then cured and have a nice finished surface area. So I'm going to talk about each of these steps and what's very important from a contractor perspective when discussing each of these parts in the process. First is surface preparation. Surface preparation is absolutely crucial. It's very important for a UHPC overlay or any type of overlay. There's different ways that can be done. Most of them are thin lift removals. Here you can see it's hydro demolition, where we prepared the deck. There was almost a 2-inch removal. But basically what hydro demolition does is hydro demolition gives you the best prepared surface for any type of overlay, because it takes rid of gets rid of any type of deteriorated concrete, takes it right out. What hydro demolition does is it doesn't cut the rock, it cuts the matrix. So it really does remove any deteriorated concrete quite nicely. Here, and it provides the best bonding surface. It also has no micro cracks, which is very, very important. Depending on the deck, and what we've learned too is sometimes you may want to apply some mechanical grinding first. And this is particularly really good if you have an existing deck that has been a lot of patchwork already done, because as a robot goes across here the deck and trying to remove the concrete, it doesn't know there's different strengths. So the robot is set and calibrated for certain strengths to set it up. So often what we see is mechanical milling to be done first, but then really what's important is to do then like a 3/4 inch or a 1/2 inch hydroscarification afterwards and really get rid of all these micro cracks. I get the question often, why do that additional step? Well, I look at it, we're going to put a material on that's going to last for 75 years. Let's not really kind of skimp on the preparation of the deck. So here you can see the thin lift removal, and what's very important is you can see all the craters. You can see that UHPC can really nicely bond to this type of surface. And what's important is here is SSD. They're just starting and preparing this deck. We need saturated surface, dry surface to be able to bond any UHPC to an existing deck. Also, what can be done is for decks where we have to go deeper, hydro demolition works quite well to expose the rebar. This is for a deck that we did in Buffalo. You can watch the video, but you can see it can clear and clean. Even the rebar gets cleaned beautifully for good bonding of the deck. The second step, what's very important, is to have efficient mixing. Particularly if we're looking at overlays, there has to be a balance of the material supply to get to the place with the placing speed of the equipment to place the material. Early starts was just take a bunch of mixes, put high efficiency mixes on the job site, mix the material. But now we even have, depending on the job site, you need mobility, you need to get in. Often you only have an hour to set up. This year is now a different, an upgrade. The trailers are right on the mixers are on a trailer. Here we can do 45 to 60 cubic yards easily in a day, get a batch ticket. You have automatic dispensing of the admixtures, much quicker, much faster. Down here is another new equipment that's being used in Europe. This is even very good for very compact sites where it's very tight to get in. It's a 1 hour setup. This plant pops out 8 cubic yards per hour easily. It's operated by 2 people. You have very high volume, and it's controlled with just a tablet now. The mixing becomes a lot more efficient. For larger projects, this is a project we're doing right now in Switzerland. It's a 2,000 cubic yard overlay project, and that requires 130 to 150 cubic yards a day. Here, an on-site batch plant was set up. The raw materials come in bulk in 3 different types of setups: the cement, the cementitious products, and the sands. Materials are being mixed and batched in the plant, and then transported right over to the overlay on the job site, and it's a fully automated plant. What's really important, this picture shows a lot of little details. It's the material supply, as I mentioned, must be consistent, constant, to be able to ensure continuous paving. And it doesn't matter what kind of equipment's being used. In this example, this was a project in Iowa. The material is brought in buggies, but it's always very important that in front of the paver, the material is built. It's the material for an overlay is thixotropic. It's a lot thicker. It's not like what we just saw for architectural applications. So as the material is being transported and put in front of the paver, you need a machine that can place it. And what's important in the transportation is you don't get any fiber segregation. The And what a lot of people have to consider too is the equipment that you use, trying to transfer and bring the material in, because often, as you can see here with the hydrodem, you have a reduced capacity of a bridge deck. So maybe heavy equipment like a ready-mix truck, you can drive on it, or sometimes what you see here is the rebar is exposed, you can get to it. So site access becomes very crucial in transporting the material. And depending on the material supplier, sometimes the material needs to remain agitated or not, but it's very important as the material arrives in front of the paving equipment that it's still uniformly mixed and you don't have any fiber segregation. Now let's talk about consolidation. There's various different methods of doing it. Here in this picture, you can see an air screed. A lot of overlays have been done or being used, and they work for small projects quite well. And if you don't have a lot of access to it, or you don't have steep slopes or crowns inside a deck. So these are things that need to be considered. However, what the machine is, it's very light. Sometimes when you have a very thick, you won't get enough vibration probably for an overlay where you need more than 2 inches. It's not controlled vibration. It's fairly slow, and it's the equipment cannot span very far. So you often can maybe do just a single lane. Otherwise, it bounces a lot, and it's really difficult to control. This one is actually set up right. You can see it's set up on railings. I've seen many contractors that just put the screed right on boards that are along the side. And that really is just vibrating the sides. You don't get any proper consolidation in the overlay. So just as a word of caution, when this type of equipment is being used, there's some challenges, and just to be aware of that it has limitations. Another equipment is Thin Lift UHPC Paver. Again, you saw in the previous pictures here, it's ready for a setup. This paver, for example, can do anything from an 8-foot up to a 30-foot wide lane, and can even go wider. Segments can be added to this equipment. It has, we said, a minimum 1.25 inches, again, because you do need, there's a lot of discussion in the industry right now, what's the minimum thickness? But if you do 1.25 inches, quarter-inch tolerance, grinding and grooving, you get a 1-inch overlay. Hence 1.25 inches. This machine, you can really monitor the frequency range and what kind of vibrations being used. It's very important. It self-propels itself, has adjustable legs, easily can do anything up to a 10% slope. So you can handle very stiff mixes and can give and provide a very uniform surface with proper consolidation, particularly for thicker overlays, and it can be very quick. This one here, you can easily do probably 100 to 150 feet an hour. So the next step is in an overlay is curing. Very important. So we've done a lot of work. We've placed the material, installed it properly. Now the curing. That's where it all comes down to. In North America, we always apply right away curing compounds. And then after the curing compounds, a plastic sheet is applied to really prevent any dehydration, to protect the overlay against any wind, temperature, or any relative humidity changes. And then depending on the projects that's going on, curing blankets are being put on just to make sure that the heater stays and remains in there. What we have been doing too, and the industry is doing a lot of it, is also adding sensors to the overlay, just to really understand the strength gain through the maturity measurements. It's very important because you need about 11 KSI before you can put a grinding and grooving equipment on there. It works very well, and we usually put sensors in right at the beginning, at the end, so we have a good understanding on how the strength and gain is in an overlay. And then the final finish is obviously the finished surface. This is why I said you need 11 KSI. You have some heavy equipment on the deck that goes on it. Here's your grinding machine, and it's doing the first path, and then the second machine that comes in to apply grooving. So you get a very nice, beautiful finish. It's very smooth. It rides very nicely. What people need to remember, depending on what type of UHPC material you use, but they all have entrapped air. and trapped air happens, some more, some less, but it really happens through the mixing process, and you can see small little holes there. However, it's nothing to do with durability. It's purely aesthetic. They are watertight. There's no chloride ingress. The deck is performing as it needs to perform. We've done a bunch of projects. I don't know how much time I still have left. I don't want to talk about it in too much detail, but this is one is the Delaware Memorial Bridge, and there we did in three. It's a pilot project. We completed that in 2020. There was 3 sections were done on each of the spans. You have a girder span, a truss span, and the suspension span. In total, 1,000 feet of UHPC were placed at a 3¼ inch thickness. And for this particular project, here you can see again during the process we're replacing all the work was done at night. But one of the challenges was we had to place 90 cubic yards in an 8-hour shift, which was easily completed with the setup there. Another project here is in New Jersey. We did in 2020 here. There was 3 bridge structures involved. There was headers that were done out of UHPC on one of the bridge structures. Then the UHPC was placed against it, and an asphalt overlay was put on to this particular bridge, one of them. That one is still currently the longest continuous pour for North America, where we did 340 feet in 1 day. And the Bruckner Expressway. That is another project that came up quickly. What was very important for this particular project was 14 cubic yards were produced in 2 stages, and it was all done within 9 days. So each of the half of the bridges was done while we had a lot of fast traffic going right beside us. So again, a lot of was very tight access to get into this project. But again, it's really to be prepared and set up. Now, those are the important slides that I want to talk about from a contractor's perspective, is the risk management. Very important when looking at projects, what has to be looked at, the quantity overrun. It's the same thing as because you have an existing deck, you're removing a lot of deteriorated concrete through hydro demolition, so it's very difficult to understand how much is being deteriorated and has been removed. So what needs to be looked at is how to manage the schedule, the repairs, what's being done between the hydro demo and the UHPC, the site access, traffic staging. Also understand when you get from a contractor or from an owner's perspective, from a contractor perspective, get pricing from a material supplier, understand what's all involved, and really the lack of experience and know-how. Quality, very important. To always have a clean, no loose material, have a backup plan. If you have a contractor that has experience, it really helps. They can do the QC. Curing protection is important, and always do a dry run. The dry run is very important before an overlay. And this is for the owners. Something to consider when you specify it. There's no consistent spec yet on UHPC overlays in North America. There's lots of variants out there, but it's very important to have a performance spec. There's many available now, many materials that work. We really recommend as a contractor always to have a mock-up, because it really shows and contractors can learn what's going on. Have an equipment selection part in there as well, because that really helps to specify proper. And what's really important is how the pay item is measured. And that's hydro demolition is usually in square yards, but then for an overlay to really reduce the risks is specify how much material is actually being used and can easily be measured on a job site. And then the work performed can either be in cubic yards or cubic meters. That wraps it up. Thank you very much, Kai. Thank you for everybody for participating. If you have any questions, here's my contact information. Please reach out. Feel free. Drop an email. Check us out on the website. A lot of the projects we've done, you can see there as well.
Thank you, Peter. Big round of applause to you as well, too. Very interesting, and it's great to see that UHPC application moving forward with overlays here in the United States and North America. It's excellent. Great pictures, very impressive. There are a lot of interesting questions here. More can be posted in the Q&A session. You can follow up with this. The time is a little bit tight, But I would like to have Adele addressing one question, and then I have a short question for you, Peter, as well, too, from the.
Sounds good.
Adele, please go ahead with your question. I see your hand is raised.
Oh.
Thank you very much, Mr. Peter, for the for this presentation. I just have one simple question. Do you have any plans in the future to incorporate your interesting UHPC in tilt-up constructions?
In tilt-up constructions?
Yes.
For particular precast elements, or
whether precast or prefabricated panels.
Yeah, so tilt-up applications or field cast applications. So personally, for us, UHPC Solutions, we are contractors, and we have know-how in mixing and placing. We don't have to look at it. At the moment, we're not looking at this type of market, but it depends on the application, what can be done, and how to, we can talk about that, Adele.
Okay, thank you, Peter. And a quick one here is from Mike from the audience. So he is more interested in the similarities and differences in mechanical properties and shrinkage between the UHPC and the underlay. So for example, is there any more concerns about cracking going on if you have a higher modulus of elasticity for the UHPC than the underlay? So are you concerned with more cracking? And in any other in terms of shrinkage, does it cause more shrinkage cracks or something? So, or does those two materials just work together nicely?
Yeah, so again, for UHPC, there's different type of UHPCs. Again, from different manufacturers, some claim to have less shrinkage or more than others. At the end of the day, basically, we have the fibers in there, and basically in the UHPC overlay, today, the industry uses about 3.25% UHPC steel fibers, and there's a lot of discussion if this is that much is required or not. However, a lot of the shrinkage is being controlled or helped with the fibers that are in the mix. Personally, we have not seen any of that, and it works very well. We have very tight, the overlays are very tight, and you don't see any of those type of shrinkage cracks.
Okay.
When you go back.
Thank you, Peter. And the last one regarding the freezing and thawing. So after sawing and proving those, right, you see like all those additional like little valleys where the winter salts could stay in there, could even increase the ionic concentrations there. Do you have any concern that those grooves expand during freezing of water or are more susceptible to
Not at all. It's a very common practice to use grinding, grooving, and for regular pavement roads. You've seen a lot of concrete pavement roads that use this type of application. Particularly, the grooves are long enough; it's big. So even if water gets in, it won't expand. It has a longitudinal direction, not only in the width. So there's enough room that the water can expand and contract. So no, I don't see any concerns with that from my perspective.
Excellent. Thank you. Then I wish you a bit of success for the future, and probably we hear from you soon again. Thank you.
Thank you.